show using a proper diagram how unpolarized light can be linearly polarized by reflection from a transparent glass surface. Okay, I will explain this one with the help of a simple diagram. Assume a glass is there here. A glass is there here. Assume this is a glass. A light rays will be passed here. A light ray will be passed in this direction. If this light ray, we call it as an incident ray. Incident ray. Okay, when it passes over the glass, if it is a move along this like this, then this ray we call it as a refracted ray. Refracted ray. And if it is like this, then usually what it will be reflected in this direction. This is what we call as a reflection ray. This is the reflection rays. Okay, and as we know that whenever an unpolarized light strikes an glass surfaces, it gets partially or completely polarized. Okay, that is when the angle between the refracted ray and the reflection ray, angle between the refracted ray and reflection ray is 90 degree. That means the angle between these two angles is equal to 90 degree. Okay, this can be linearly polarized from the reflection from a transparent glass. Okay, this is we can say it is a completely polarized. It is completely polarized. And the second part of the question is, the figure shows the ray of light falling normally on the face AB of an equilateral glass prism having a refractive index 3/2 placed in the water of refractive index 4/3. Will this ray suffer total internal reflection on striking the surface AC? Justify your answer. That means when a ray is passing perpendicular to the AB or an equilateral prism, this ray it will be extended to the further extent like this. Okay. Now this is value, this angle, that means I can say this angle is equal to a 60 degree, and this angle, this is 90 degree, and actually I can say this is an angle which is equal to 30 degree. Okay, and here the value, that is mu IC, here the value mu IC which is equal to the refractive index, that is 3/2, and when it is placed in water, the refractive index, this portion if it is placed in the water, the refractive index that is equal to 4/3. And we know that the total internal reflection condition is, that is a mu1 sine IC is greater than or equal to mu2 sine 90 degree. Here the value of mu1 is equal to 3/4 sine IC is greater than or equal to mu2, that is equal to 4/3 Okay, then sine IC is equal to, we can say that is a 4 times 16, that is a it is value, that is it is 3/2. This value is 3/2. It is not 3/4. This is 3/2, and this is becomes 8/9. 8/9, and the IC value is equal to sine inverse of 8/9 value. It is approximately, which is equal to 62.7 degrees, which is less than 90 degree. Then the total internal reflection, what takes place?